Hello everyone, let's solve AP Precalculus Free-Response questions from 2024, and this is question number 4, which is a non-calculator question. So let's read through the directions first and then start solving it. As usual, it says that the domain of function is assumed to be a set of all real numbers. Fx is supposed to be a real number. Angle measures for all trigonometric functions, we must remember, will be written in radian form only. Solutions to equations must be real numbers, and wherever possible, you must determine the answer for an expression or the exact value for any expression that can be obtained without a calculator. For example, log base 2 8, cos pi by 2, sine inverse of 1. All these expressions which you think you can evaluate without a calculator must be evaluated. Unless otherwise specified, we must combine all algebraic terms using algebraic methods, laws of exponents, and logs. Another part says that for each part of the question, you should show the work that leads to your answer. So after reading the directions, let's just jump onto the questions. The first part of the question says GH are defined by e to the power x plus 3 and hx is defined as arc sine x by 2. For the first part, we need to solve for gx is equal to 10. Let's see how should we be able to solve for gx equal to 10. So for gx equal to 10, we substitute e to the power x plus 3 equal to 10. Now to solve further, we have to use the inverse of e, which is ln x. So we say x plus 3 can be written as ln of 10. This is the reason because if e to the power x is y, then x can be written as ln y because ex and ln are opposite or inverses of each other. Now to find out the exact value of x, we can say it is ln 10 minus 3. Don't get confused with the 3 being subtracted in the argument. It is to first evaluate ln 10 and then subtract the 3 from it. Reading the second part of the A part, it says hx equal to pi over 4 can be found out for all values of x in the domain of h. Now, to find that out, we have arc hx equal to pi over 4, which would mean I have sine inverse, because arc sine is a sine inverse function, sine inverse of x over 2 equal to pi over 4. X over 2, because to find out the inverse function, we can take the sine to the other side, which means I can evaluate sine pi over 4. X over 2, sine pi over 4 has a value of 1 over root 2, which means x over 2 has a value of 1 over root 2. Now I can take the 2 to the other side in multiplication, makes it 2 over root 2. And if possible, just rationalize your function to give a better answer. By rationalizing, I will get 2 root 2 over 2. 2 and 2 would cancel and this will give me the answer of x as 2. So the possible value of x is 2, which gives me sine inverse x by 2 as a value of pi over 4. Now let's solve for the B part of the question. The question says that jx and kx are functions given here. One is a logarithmic function and one is a trigonometric function. The first part says, can you write down jx as a single log base 10 without negative exponents keeping in mind and in any part of the expression, and your result should be of the form log base 10 and then the expression written. So let's try using log laws to simplify it as much as we can. Remember, the log laws that we have are log base am plus log base an is log base a mn, which means that if they're being added, their arguments get multiplied with the same base. Similarly, if they are being subtracted, log base am, log base an, then the arguments get divided in that case. And we have one more log law, which is if I have log base a m to the power n, then that n gets multiplied, which is n times log am. So let's keep keeping in mind these three log laws. Let's try and simplify the first part, which is the gx. To simplify that, we have gx must be written as a single logarithm. If I look at the first two parts, it is log base 10 8x5 plus log base 10 2x squared minus 9 log 10x. Now, log, the first expression and the second expression are being added with the same basis, which means they will get multiplied. So it will be log base 10, 8x5 into 2x square minus. Now this is a constant in multiplication with the log, so it can move to the power of the log, which is log base 10 x to the power 9. Now when I multiply this expression, it gives me log base 10, 8 times 2, 16. And using laws of exponents, it will be x to the power 7 minus log base 10 x to the power 9. Now these are being subtracted, so using log laws, I will divide them. Log base 10, 16x7 divided by x to the power 9. The powers of exponent would get cancelled and I'll be left with log base 10, 16 over x square. So that's how I've simplified it. I will just write it like this. I will not make x square as a negative power because the question strictly says without any negative exponents. Now looking at the second part, it says rewrite kx as a single term involving tan x. So my expression has to be in tan x. For now, kx says 1 minus sine square x divided by sine x into sec x. Now I have the property of trigonometric functions as sine square x plus cos square x equal to 1. Using that identity, I can replace 1 minus sine square x as cos square x over sine x into sec x. I also know sec x is the inverse of cos x, which is sec x can be written as 1 over cos x. So I will replace it here, 1 over cos x. Cos square x and cos x would just cancel out and I'll be left with cos x over sine x. Now cos x over sin x is cot x. However, I need to write down my expression only involving tan. So what I can do is I can bring the tan, the cos in the denominator, making it 1 over sin x over cos x, which will give me 1 over tan x. So writing down the expression only in terms of tan x, kx can be written as 1 over tan x. Let's move on ahead. Now we can discuss the C part of the question. This is a good question which says mx is cos inverse tan of 2x. We have to find out all values in the domain of M that yield an output value of 0. Let's understand how would we solve for this question. So we have been given mx as 0 and we have to find out all values of x, which will give me mx as 0. So substituting the function, I have cos inverse tan of 2x is 0. Firstly, when I solve for it, I have to take cos inverse to the other side, which will make it a cos function, which is its inverse function. So tan x is cos 0. Now tan x cos 0 I know has the value as 1. So tan 2x basically is 1. Now keeping in mind what all values of tan give me 1. So in the first quadrant, tan gives me a pi over 4 value. However, we should keep in mind that tan becomes positive in the first and the third quadrant, where it is pi over 4 and then again pi plus pi over 4. So a generic expression to write down tan x, we could say tan 2x is equal to pi over 4 plus pi n, where n belongs to the set of z or n is an integer, we could say. Because every time you substitute any value for n here, this is what your generic equation would be, because it is always pi plus theta and theta there in the first quadrant. And if you keep revolving about coordinates, it will always be of that form, right? Because if I substitute n as 0, I will get pi over 4. If n is 1, I'll get pi plus pi over 4. Again, if n is 2, then it will be 2 pi plus theta, which is again the first quadrant, right? So this is my generic expression or my general solution for this. And to solve for x, we will finally say, so this is not tan 2x, this is just 2x is equal to pi over 4, because these are the values of tan or the values of theta which are giving me this value. Now to solve for x, I will take the 2 to the other side. So pi over 8 plus pi over 2n, where n belongs to c. So this is my set of values from the domain of x, which are giving me this whole expression as 0 and specifically are giving me tan 2x as 1. Always remember to write down general solutions for your trigonometric functions and not just restrict yourselves to values in the first 4 quadrants, because it says, can you find out all values in the domain? So try mentioning all the values or the general solutions in this case. So this was a good question on using log laws and trigonometric function equations, moreover using trig laws as well to solve for it. I hope you understood.